Hi for people that watch this later on in life.
All right, Johnny says hi. We are on lesson 0-8. The title of today's notes is Solving Absolute Value Equations. We are on Standard C. What is Standard C, class? Standard C. Johnny, what's Standard C? Be looking for it. Daisy's looking for it. Jack is now starting to look for it. Sarah's copying down notes. What is Standard C?
Solving equations and inequalities.
Yep, Jack has it. Solving equations and inequalities. So today we're doing more solving equations. We are not quite at solving inequalities yet. I think we have touched on it a little bit, but here we go. Absolute value. Can you guys talk to me? What do you think absolute value is in your own words? And think about this. Once you think you have the answer, go ahead and raise a silent hand. What is absolute value? Be thinking about it. Johnny, be thinking about it. Absolute value. Absolute value. When I say absolute value of -7, you're like, oh, I know that. What's the absolute value of 5? Oh, I know that. What is it?
-5.
Well, don't answer it. Just this is to help you think. What is absolute value? Or at least what's the procedure if you don't know what the actual absolute value means? So Jack has a hand raised, so that means he's ready to answer. There's only one person that has a general idea of what absolute value is, though. Okay, Jack, give it to us.
Absolute value is like the opposite of the number. If you have 5, absolute value is -5. If you have -7, absolute value is 7.
Okay, what if I gave you 7?
If you give me what?
If I gave you 7, what's the absolute value of 7?
-7.
-7, so you just flip the sign?
Yeah.
Okay, so what you're thinking is the definition of opposite. And I'll write that over here, opposite. Opposite, this means change the sign. So when I change the sign, that just means I go from a negative to a positive or from positive to a negative. So give yourself some space to write the definition. I'm going to give you some really quick examples from absolute value, and you can see what the pattern is. So here's some really quick examples. The absolute value of -7, as Jack said, and I make my absolute value signs kind of tall, that way I don't confuse them for ones or something. Absolute value of -7 is 7, I agree. Absolute value of 5 is 5.
Oh, it wouldn't be -5?
It's not -5.
Oh,
That's the opposite.
In the absolute, it's like always a positive basically.
Okay. So Jack, say that one more time for us.
When it's in absolute value signs, it's just always a positive.
Okay. We have some agreement in the class, or
Yes.
Your answer is
Yes.
always positive.
always positive? So yes, you are correct, but you have to be careful about how you say it. So the true definition is the distance. This is the
told you
distance.
you're wrong.
No, he's right. It's always going to be a positive value, and this is the reason for why it's always positive. He correctly identified the pattern. This is the distance from, where do you think it's from? From a certain number.
0.
From 0. Johnny has it. So when I'm talking about distance, and assume that you're not talking about negative vectors or anything, so you don't have something weird going on, is it ever possible to have negative distance? I'm talking about real world here. Can you go a negative distance?
No.
Oh, look, he just walked -2 yards. No, he walked positive 2 yards in a certain direction. You can never have negative distance. And from the definition of what absolute value is, you get Jack's rule. It's always going to be positive. So you can make a note over here, I'll do it in a different color, that distance is always positive. Okay, so another visual representation. I know some of us in here did score on the visual part of our how we learn. So if I make a number line and I say I'm looking at, there's 0. I want to find the distance from 0. So here's 7. How far away from 0 am I? I'm at 1, 2, 3, 4, 5, 6, 7. I'm a 7 distance away. Or if I'm at -3, so that was a distance of 7. How far am I? I'm at 1, 2, 3. 3 distance. So you should always kind of think about it in the number line version. So that's the visual representation. Or you can think about it in the numeric representation, just the algebra, the numbers on a piece of paper, that you just always make it positive. I am trying to become more and more of a visual learner myself. So I'm trying to see this as a number line more so than just the numbers, absolute value signs. Okay.
Wait, so on the top of, like on the number line,
Yes.
3, it should just stay 3. It shouldn't be -3.
No, yeah, because you're right. So the 3 stays -3, not -3, because this is counting distance. And as I said in parentheses here, that's always going to be a positive number. So these numbers count distance, and maybe I should label those as, I can abbreviate distance with DIST. So that's a distance there, and this is also a distance right there. All right. Do we have questions before we move on to actually solving these guys? Not yet? Okay, so if anyone has questions, just raise those hands. Okay, I want to start talking about solving simple absolute value questions. Can't speak. Solving simple absolute value equations. So go ahead and label this over here. Solving simple.
Did that say something?
Simple absolute value equations. Okay, I can spell here, Mr. Sindel. Johnny, that's going to go in the trash can, not at your pier. All right, what do I mean by simple? And this is kind of a word that I'm just kind of arbitrarily using here. What Mr. Sindel means by simple, we'll put simple in quotes because this is a Mr. Sindel word. It doesn't mean everything, or it doesn't mean the same thing to all mathematicians. What I mean by simple is this. I'll do an arrow. Simple to me means that the absolute value equation, or the absolute value sign, this thing, that is alone. It doesn't have any numbers added to it. It doesn't have anything multiplied by it. No distribution that has to happen. So it's alone, and it's on one side. Oh, my pen just decided to hiccup on one side. In this class, we will never see an absolute value equation where it's absolute value equals an absolute value. That can be solved, and it's kind of a lot of steps, but for now, just worry about one absolute value sign on one side. We will have stuff added to it and subtracted to that. We'll do that in this lesson today. All right, I'm going to give you guys the procedure. Again, we had our discussion about what true mathematics is and how this kind of kills your creativity, but we need to go fast through this in order to get all of the material. And I think that a lot of us will benefit from these procedures so that you can apply these over and over again to the problems that you will see on the test, on the quiz, on state tests. It's going to be the same thing over and over again. Here we go. Procedure. And maybe you don't like the word procedure. Maybe you want to use the word steps. There are essentially 4 steps when it comes to solving absolute value equations. Here they are. Step 1, 2, I'm squeezing them in here, I'm running out of room, 3, and 4.
3 and 4.
Step 1. I want to get the absolute value sign, so I'm going to do get these guys alone. So let me give you an example. If we had the problem absolute value, so I'm going to do this in a different color on the side. We have the problem absolute value of 2x plus 3.
Can you put like an X between those or something? Like between the ones, it's bothering me.
Between the absolute value bars?
Yeah, it's bothering me. I don't know why.
Yeah, I can see why you might be bothered. It could mean parallel and it's empty. I'm just going to have to do it like this so it's sweet and concise notes. You can do it differently in your notes. Please don't copy down exactly what's going on in my notes. You can put an X in there. And that's the point of notes. Go ahead and change it to whatever suits your needs.
It's just bothering me.
All right, so I need to get the absolute value bars. I need to get them by themselves. But luckily for us, in this problem, they've already been given by themselves. So just go ahead and say, check, I'm done for step 1. Step 2, I'm going to call this bending the bars. So call this bend bars. Has anyone seen Futurama?
Bender.
That's what I'm thinking of too. By bending the bars, what I mean by this is the absolute value sign gets bent into just a parenthesis. So I'm going to rewrite that over here. The parenthesis is now 2x plus 3 parenthesis is equal to 4. I bend the bars into these parentheses. Okay, this is probably the most crucial step here. I'm going to make, and the words I'm saying here are going to be a little bit weird the way that I write them down. I want to say I'm going to make a positive path and a negative path. The way that I want to do that in my notes is by saying make positive and negative paths. I'm going to do positive and negative paths. But to you guys, you should know that there's going to be 2 paths. One of them is positive, one of them is negative. And then step 4 is just to solve. And I don't want to just write solve by itself. I want to say solve both paths. Both paths. My pen is like dying on me. I don't know why it's not writing correctly. I think it's because I'm recording a video and it doesn't have enough processing. So by making positive and negative paths, what do I mean by that? Let's look at solving this problem. So my first path is going to be my positive path. So this is going to be 2x plus 3 is equal to 4. It's the exact same path. It's positive. Positive is usually leave it. Okay, here's the negative path. Are you guys ready? Here comes the negative path. I'm going to rewrite the left-hand side. 2x plus 3. I rewrite it. And then everything that wasn't inside the absolute value sign gets changed. So when it comes to an inequality, that means this sign right here will flip. But since we don't have anything to flip, that stays the same. And I take the opposite, and look, we define the word opposite. We take the opposite of whatever this was. Opposite of 4 is?
-4.
-4. Jack has it. I have made a positive path and a negative path. So I did step 3. And then I need to solve for both paths. So go ahead and solve those. In my notes, I'm going to go ahead and just give us the answers after you guys solve them, of course. Go ahead and solve those.
Can they be fractions or?
They will probably be fractions.
Yeah, they're both fractions. Of course they are.
Once you have them solved, go ahead and check the board to make sure you have the right answers. This is a good way of checking your answers. The best way of checking your answers is to plug in the number into x in the original equation, which I gave up here. I plug in this 1/2 into x and see if it does in fact equal 4. If I did that, 1/2 times 2 is what? People that are done. 1/2 times 2
1.
is 1 plus 3,
4.
4. Absolute value 4 is?
4.
Yeah, so that one worked. And -7/2 should hopefully also work.
Oh, rat.
And I should be writing this underneath here, but I ran out of room. Can you write this underneath in your notes? That the answer here needs to be written like this, and it's very specific. X is equal to, and it's called a solution set. X is equal to, and you do a curly brace, and another curly brace. I'm going to do the smaller one first. What's smaller, -7/2 or 1/2?
-7.
You are correct. -7/2. Why is it smaller again, Syra?
Because it's negative.
Because it's negative. And then I'm going to do a comma, and then the second answer, 1/2. This thing is called, whenever I have these curly brackets, that's called a set. So this is the set of solutions, or more succinctly, the solution set. We are almost done with the notes. We did a simple absolute value equation. I want to do a more advanced absolute value equation. And then we can be done for the notes. Once I see everyone's pencils down, I will move on to the next slide. All right, next slide. So this next title, I want to call it Solving Complex Absolute Value Equations. So, solving complex absolute value equation. And you can abbreviate here, absolute value. You can do ABS period VAL, absolute value, and then I can even abbreviate equation. And again, I'm using this new word here, complex. And this is a Mr. Sindel defined word. If you talk to another mathematician, they would not know what you mean. They would roughly know what you mean. But this is my definition of complex. I'm going to just say stuff on the outside.
Stuff's not a good word.
Stuff. Yeah, if you're in English, they'll, I don't know, smack your wrist with a ruler or something. Outside of the absolute value. So an example of this would be, well, I'm going to do one below here, so get ready.
You're gonna do what?
I'm going to do another example, and then we'll be done. Ejemplo número 2.
What?
This is in Chinese class.
Oh, I got it.
All right, here we go. I want to solve this one, and I'm going to write it on the right-hand side over here, and I'm going to rewrite the same steps, 1, 2, 3, and 4, because it is the same 4 steps. So here I go.
Do we have to write it too?
I would like you to write it this way too, because it really helps you understand what's going on. If you think you have those 4 steps down, then you can change your notes to be like that. As long as you have the 4 steps from the previous slide, you're good. All right, so my equation that I'm going to start with, I'm going to write it next to the example here, is going to be 3. What the heck is going on? You guys believe me now that my pen is like messing up, right?
No, you're just messing around.
3 times the absolute value of 2x minus 8. All of this, add 2, and I'm going to say that is equal to -1. Before I even move on, I remembered that there's something that I forgot to go over, and I'm going to put it on the sidebar because now is a good time now that I'm remembering it. So if I have the absolute value of anything, absolute value, and maybe Johnny wants to put like x or something in there, absolute value of anything, what can this quantity be?
Anything.
Can it be a -5? Can this equal a -5?
Yeah. No.
No, it can't. Why?
Because
It has to be positive.
It has to be positive. How can we write that in notation that it has to be positive?
you can just put
Put has to be positive.
In notation, using symbols.
Let's put a couple
Positive number
positive
and
signs.
exclamation point.
Positive number, an exclamation point. How about this? I want to use an inequality, greater than.
I'm just kidding. Oh,
How can we use an inequality, greater than?
Just do like
this way?
do like a positive sign and circle it and scribble under it really hard and some arrows.
Okay, that would be one thing. Can I show you what most mathematicians use to say only positive?
Yeah, do they just use greater than 0?
They say greater than 0,
I'm
yeah.
not gonna make it for you to say.
So can we write this in the side notes? If I have something absolute value, it has to be greater than 0. That's another way of saying it has to be positive. That's the symbolic form. If you want to write under here, it has to be positive, write an arrow, has to be positive to remember. And you like this plus with a circle, that actually does mean something specific in math, but we'll just go say it has to be positive, then that works too. Or maybe you like the words POS, positive.
POS. Poop on a shingle.
No. Which means, guys, that if I have this absolute value of x and I say that's equal to -3, are you guys ready for the answer? What do you, no solution. There's nothing in the world of mathematics that I know of, at least, and I know quite a bit about math, as you might expect.
No.
There's nothing in here that I can put in for x such that I get a negative value. So there's no answer. There's no solution. We got it? We'll eventually have some of these on the homework where it's like, this has to be greater than -3, or it has to be less than -3. That's impossible. But you'll probably forget about that, and you'll just go through the 4 steps. So the first step, the step 0, I guess, is check to make sure you're not equal to a negative. All right, here we go. So, what was step 1? Do we remember? Step 1.
Step 1 was to get the thingy by itself.
Get, what do I call this thing?
Absolute value.
So let's distribute 3.
So you can't distribute because it's blocked by this wall, this absolute value. So we have to move it to the other side. So how can I move these numbers to the other side using correct order of operations, correct solving for the equation? What am I going to do first? Am I going to get rid of the 3 or the 2 first? Am I going to move the 3 or the 2 first?
The 3,
The 2.
I hear 2 different answers.
the 2,
The 6.
and
The 6. I mean the
the
6.
6.
Whoa.
So I can't move anything in the absolute value. I want to keep that by itself. I'm either moving the 3 or the 2. Tell me what to do, Johnny. What do I do?
Subtract by 2.
Subtract by 2, so my new equation becomes what?
3 times
Absolute value of?
absolute value of -8 equals -3.
Perfect. So we're getting there. We haven't finished step 1. Can someone do the final step to get the get the absolute value by itself?
Ooh, you
I'm just kidding. You divide by 3.
So my new equation becomes Daisy?
Bruh.
The absolute value of 2x minus 8 equals 1. Wait, 0. Wait, just kidding. What? 1. Isn't it 1?
Equals
Negative 1. Negative 1.
negative
No,
1.
it's just. Oh, yeah. Guys, I'm just kidding. You know it's a name.
I know bad words, and I know that was a bad word.
Guys,
That's not a bad word.
that's not a bad word.
Starting with P?
P. I didn't say a bad word.
No, Syra did.
Oh my god, I'm sorry.
All right, so what's the next step?
Pegasus.
What's the next step?
You gotta do bend the other way around.
Bend the bars?
No. Wait.
What's step 2?
Yeah, bend bars.
Bend bars?
Boom.
Trick question. It was a trick question. Now that you know it's a trick question, what is the answer?
It's no solution.
No solution. Because step 1.5,
Girls be tripping over here.
check that it's not equal to a negative.
1.5.
That's 1.5.
You're 1.5.
So the correct answer here is no solution.
Did you spell cheek?
What?
Check to make sure it's not equal a negative. Or you could say check to make sure it's positive. Check to make sure it's greater than 0. I think it would help our class to go over one more example that isn't a no solution. Do you guys agree?
No.
Yes.
I'm going to do it.
Can I just do the homework now?
Go ahead and do the last example with us, Johnny, and then you can do the homework. All right, here is our final example.
I don't know what's wrong with
Oh, man.
All right, here we go.
Oh my god.
I'm going to say my new equation is 3. What is going on here? I need to go to black. Guys, follow along with me. 3 times the absolute value of 2x minus 8 plus 2. I'm going to be making this equal to,
12.
if I do 12, what about 11?
11?
Yeah. It'll come out a little bit nicer, Jack, I promise. All right, so let's go ahead and do step 1. Step 1 again was
Oh, that's kind of nicer.
get absolute value.
Get rid of that 2. Minus 2.
Okay, I'm going to subtract the 2, and I get 9. And then what do I do from there?
Now divide that 3.
Okay, so my new equation becomes absolute value of 2x minus 8 is equal to 3. I'm going to pause and make sure that we follow those 2 steps. I subtracted the 2. 11 minus 2 was 9. And then I divided by 3. 9 divided by 3 is 3.
I'm just kidding. 11.
Make love.
All right. I'm going to go kind of fast here to make sure we get to the homework. Number 2. Bend bars. Can we not swear in this classroom? That would be nice.
What did they say?
What's step 3?
It's
Make positive and
negative
or
paths.
negative paths.
Make
What?
positive and negative. What is going on with my marker? It's just dying.
It's not dying, it's just retarded.
it ran out of ink.
Oh, what the heck?
That's
Tats.
I'm done. I'm so thirsty.
Okay, so here we go. Keep up with me, guys. 2x minus 8.
What would I drop the other time?
Oh, come on. I wrote it. Where is it? Equals 3. There's the positive path. Here's the negative path.
Can you do the negative first?
You can do the negative first. That works too.
Racist to negative.
Oh, you gotta be positive, don't you?
Step 4.
Check.
Solve. Oh, my pen. It just is not working. I'm so annoyed.
Solve both paths.
It's because you want it to work.
Of
If you don't want it to work, and it won't work anymore.
I don't know which of anyone this works. So I'm gonna check.
I'm writing, but it's not working.
Ooh, he innately.
All right, and then we get our final answers of x is equal to 11 over 2, and x is equal to 5 over 2. Our solution set is, I'll do it on the side again because I ran out of room. 5 over 2, comma, 11 over 2. All right, that's it. Go ahead and write your summaries. I'm going to stop the video. Thanks for watching.